Hi, I'm Coach Cowland, and in this presentation we're going to be looking at friction. I'd like to start by asking you what you think friction is and note down anything you already know about it. Also, why do you think that it seems easier to move something once it has started moving rather than to get it moving in the first place? Pause the video, write down your answers, and then continue. Friction occurs when molecules try to pass each other and encounter resistive forces. These forces always act in the direction opposing the motion. This is an important point. Friction is a force that is dependent on the materials and hence the molecules that are interacting with each other. The upshot of this is that when some materials, such as polish and socks, interact, friction is low, whereas with other materials, such as carpet and sneakers, interact, friction is much higher. Finally, friction is related to the normal force between two surfaces. We'll be looking at three types of friction. Static friction is the frictional force that stops things from beginning to move when they are stationary. Kinetic friction is a frictional force that affects things when they are in motion. Both static and kinetic friction are very similar to each other, and we will spend most of our time focused on these two. Air resistance is caused by the air pressure of molecules interacting with objects passing through it. Let's look at static friction first. Static friction prevents things from moving that are already stationary. The equation for static friction is Fs, that is the force of static friction, is equal to μs times normal force. μs is the coefficient of static friction, and we'll take a closer look at mu later in this presentation. Now let's look at kinetic friction. Kinetic means motion, and kinetic friction is the friction of things that are already in motion. The formula for this is almost the same as the formula for static friction. Fk, the kinetic friction, is equal to μk times the normal force. μk is the coefficient of kinetic friction. Generally, and between the same two surfaces, static friction is greater than kinetic friction. This is part of the reason why things seem easier to move once they're in motion. We can sometimes use the force of friction to help us with calculations. For example, if there is no acceleration and there are several forces acting, the friction must be equal to the force of motion moving the object forward. Sometimes it can be easier to calculate the friction and deduce the forward force than to calculate the forward force directly. You may think that friction is annoying, but in real-world situations, friction is immensely useful. Without it, we'd never be able to stand up. Cars would be terrifying death traps because tires wouldn't grip and brakes wouldn't stop you, and things would slide forever. Mu is the coefficient of friction. It is a value between 0 and 1 that is used to calculate friction. Mu has no units, and the higher the value, the higher the force of friction. Mu is different for each pair of interacting surfaces and also gives different values for kinetic and static friction between the same objects. In almost every example, mu is greater for static friction than for kinetic friction. Air resistance is a special type of friction. Because air is fluid and can move around objects, the objects passing through the air disrupt the motion of the particles. This causes resistance to motion. The amount of air resistance is dependent on several factors. First, the amount of air that is disrupted. The bigger the front area is, the more air will interact. Second, the shape of the object. Big squared things mean it's difficult for molecules of air to flow around them. Third is the rate at which the object is moving. The altitude and hence the air pressure also has an effect. The higher the altitude, the lower the air pressure. This means that the air pressure is low, there are less air molecules for the object to pass through, and hence there are less interactions to cause resistance. So that's the end of the presentation. I hope you enjoyed it. For my students, I would like you all to make notes on the presentation, complete any examples in the presentation, write down at least 2 questions that you'd like answered in the discussion in class, and we will continue working on this over the next few classes. If you have enjoyed this presentation, check out the other videos, science news, and interesting blog posts on www.coachcowlandscience.com. And also don't forget to like us on Facebook. See you next time. Goodbye.